Okay, in this example, we're looking at Hughes Howlett, 6th edition, 4.4, number 23. A farmer uses X pounds of fertilizer per acre at a cost of $2 per pound, leading to a revenue of R equals 700 minus 400 e to the negative X over $100 per acre. Part A, how many pounds of fertilizer should be applied per acre to maximize profit? And let's just start with that, and we'll worry about part B in a second. Okay, so part A, let's see, what are we supposed to maximize? Profit. Okay, well, in general, profit is equal to revenue minus cost, and we've been given the revenue function, but we will need to think a teeny bit about the cost. So profit is equal to 700 minus 400 e to the negative x over 100, that's the revenue, minus the cost. And they told us, not the cost function itself, but they kind of implicitly told us it's X pounds of fertilizer at a cost of $2 per pound. So X is in pounds, the cost is $2 per pound. This would be 2X for the cost function. And that's really the hard work, or at least the part that's a little different in this problem. The rest is the same way we always find a maximum, right? So it wants us to maximize profit, so we should take the derivative, set it equal to 0. So pi prime of x. Okay, so the derivative of 700 is 0, minus 400, because the constant in front goes along for the ride. Don't change e. Don't change the inside of the exponential function, so it's still just e to the negative x over 100, and then multiply by the derivative of the inside. That's negative 100, because the inside was x times a constant, or divided by a constant. And if it's x times a constant, and you take the derivative, the x goes away and the constant stays. And actually that's the same thing that happens at the very end. We get minus 2 when we take this last derivative. It's still a constant times x. We take the derivative, we just get the constant. Okay, so that's the derivative, and then I should take that and set it equal to 0. So I'll simplify it a little bit too. So this is 0 goes away, negative 400 times negative 100 becomes positive 4 e to the negative x over 100 minus 2 equals 0. Add 2 to both sides and divide by 4. You get 2 over 4. And then hopefully you remember how to solve problems like this. We have an e, we have an exponent, we're trying to solve for the exponent. We should take natural log of both sides. Okay, I always like to write that step out, but of course mostly what the action is on the left side where the ln and the e cancel, and so that leaves you with negative x over 100 equals ln of 1/2, and so x is equal to negative 100 ln of 1/2. Okay, so you can plug that into your calculator and you find out that this is approximately 691 pounds of fertilizer per acre. So I guess actually the units are pounds per acre. And that's part A. Part B asks what is the maximum profit, and of course most of the time in this class I've really emphasized that we find the x value where maxes occur, where mins occur, and so on, but a farmer, a normal person, might want to know not just the x value, but to know what will be the profit, or in other problems, what will be the y value. So in any case, the hard work is done, but we just plug this back in, and we plug it back in, 691, all the way back up in the original profit function. We just want to find the y value of the profit where it's a maximum. So this would be profit of 691 pounds equals 700 minus 400 e to the negative 691 divided by 100, and then all minus 2 times 691. Okay, plug all of that into your calculator and you get 72,280. And that's the end of the example.